Hello, everyone. I'm Lee Hongmei from number 3 Vocational Technical School of Nanning. Welcome to this mini lecture. In the previous lesson, we have studied the multiplexing techniques of data channel. In this lesson, we will study the technologies of data exchange. The topics we will explore in this mini lecture include circuit switching, message switching, packet switching, and cell switching. The teaching objectives of this mini lecture are: 1. To understand the concept of the technologies of data exchange. 2. To master the methods of circuit switching, message switching, packet switching, and cell switching. Let's begin by understanding what the technologies of data exchange are. The technologies of data exchange encompass various techniques used to establish temporary interconnection paths for data communication between two or more data terminal devices. We commonly use for exchange technologies: circuit switching, message switching, packet switching, and cell switching. Next, let's study the first part: circuit switching technology. Circuit switching, also known as line switching, is a direct method of exchange. In this method, a dedicated communication channel is established between workstations through network nodes, creating a physical connection between the two workstations. Once the communication line is established, the endpoints exclusively use this physical channel until the connection is terminated. Common examples of circuit switching include telephone systems and public switched telephone networks. Circuit switching technology involves 3 phases: the circuit establishment phase, the data transmission phase, and the circuit disconnection, release, phase. The advantages and disadvantages of circuit switching are shown in the slide. Due to the limitations of circuit switching, the computer communication field introduced store and forward switching technology. This includes message store and forward switching and packet store and forward switching, which can be further divided into datagram and virtual circuit modes. Now, let's move on to the second part: message switching technology. Message switching uses the store and forward method, which does not require a dedicated physical line between the communicating nodes. Data is sent in the form of messages, which include user information as well as source and destination addresses. The working principle of message switching can be compared to the process of mailing a package. Typical applications include email systems and telegraphs. Next, let's study the third part: packet switching technology. Packet switching, also known as packet switching, also belongs to the store and forward switching method. However, it does not use entire messages as units. Instead, it transmits and switches data in units of limited length packets. The maximum length of these packets is typically regulated to be between 1,000 and several thousand bits. User data is divided into segments of a certain length, called packets. Each packet is prefixed with a packet header, which indicates the address to which the packet is to be sent. Switches then forward these packets to their destinations based on the address information in each packet, a process known as packet switching. A network that employs packet switching is called a packet-switched network. Packet switching has several notable features. Its advantages include limiting the maximum packet length, reducing the storage required at nodes. Shorter packet lengths make error detection easier and retransmission quicker, enhancing switching speed. And each packet can independently route to select the optimal path. However, packet switching also has some disadvantages. For instance, packets may experience queuing delays at each node during the store and forward process, leading to latency. Additionally, the headers that each packet must carry introduce some overhead. The predecessor of the Internet, ARPANET, first used packet switching technology, laying the foundation for modern computer networks. Packet switching is widely used in data transmission technology, with existing data exchange networks based on packet switching technology. Packet transmission in networks can be divided into two different modes: datagram and virtual circuit. Datagram transmission is a connectionless transmission method, while virtual circuit transmission is a connection-oriented method. In datagram mode, each packet carries complete address information independently. When a network switch node receives a data packet, it processes each packet as an independent unit of information based on the address information within the packet and the routing information stored in the switch node. The features are as follows. In virtual circuit mode, a logical link must be established on the network before the communicating parties start sending and receiving data. User data then arrives at the destination sequentially along the logical link. The features are as follows. Let's look at a comparison of the four switching methods: circuit switching, message switching, virtual circuit, and packet switching. This comparison helps us choose the most suitable switching method based on different communication needs. For interactive communication, message switching is unsuitable, while packet switching is appropriate. For light intermittent loads, circuit switching is most suitable, as it can use public telephone systems through dial-up lines. For heavy and continuous loads between two stations, least circuit switching lines are ideal. When exchanging a moderate amount of data to a large number of data devices, packet switching lines have the highest utilization. For short and flexible messages, datagram packet switching is suitable. For large-scale data exchange and reducing the processing burden on stations, virtual circuit packet switching is appropriate. Finally, let's study the fourth part, cell switching technology. Let's talk about asynchronous transfer mode, a connection-oriented switching technology that uses small, fixed-length information exchange units called cells. Cell switching technology is a fast packet switching technology that combines the high efficiency of packet switching with the high speed of circuit switching. Now, let's summarize the content of this lesson. In this lesson, we learned about the concept of the technologies of data exchange and four types of data exchange technologies: circuit switching, message switching, packet switching, and cell switching. Finally, to reinforce what you have learned, I have prepared some exercises for you to complete after class. I hope each of you will diligently complete them and internalize what you have learned. That concludes this mini lecture. Thank you, everyone.